In this video, we're looking at graphing linear equations. So there's two methods we're going to be looking at. The first one is like your foundational method, and we call that the table of values, and it works for almost any type of function or equation you're trying to graph. So on your screen, you can see we have to graph y equals 2x plus 5 on a number plane. All right. So how we use the table of values is we set the x values. We know them. So in this case, I'm going to say minus 3, minus 2, minus 1, 0, 1, 2, and 3. Because we've set our x values, we can use these to find out our y values, which just gives us a point on the graph. So if I said let x equal -3, what I'm going to do is substitute that into the equation. So y equals 2 times -3 plus 5. And that equals -1. Alright, so I'm actually going to change that color so we see where it goes. So -1. That -1 goes underneath our -3. Alright, and then we can do the next one. Let x equal -2. And what you do is replace that x in the original equation with -2. And that gives us a value of 1. So then I go up here and I put 1 in there. And you continue to do this until your table of values is full. As you can see now that it's full. So what happens is each of these, so here, that's one coordinate. So that would be at -3, -1. This is a coordinate, -1 at 3. So each one gives a separate coordinate or a point on the graph. So if I scroll down and zoom out a bit, so on the right there you can see a number plane, and we're going to plot each of these points on that number plane. So if I was doing that first point, -3, -1, you go with the x first. So I go across to -3, and then I can go up to, go down to -1 on the y. Alright, so if I get rid of those, I know it's at -3, -1, so that's where my first point is. If I do the green, we go across to -2 here, then go up 1, so I know there's a point here. Alright, and you continue to do this until all your points are plotted. So -1, 3, 0, 5, 1, 7. I'm not going to bother with the rest because they've started to go off the number plane that I've got, the range. So if I bring out my ruler, and it's not going to be perfect, but I'm going to try and get it through most of the dots that I can. So we would have that line there, and this is going to be y equals 2x plus 5. Alright? So when you're using a table of values, you make it up and you pick which x values, and you can pick anything. -3 to 3 or -2 to 2 is usually a safe bet. They're safe ones to use. It gives quite a good range. And then remember, you substitute those x values you pick into the equation, you use a calculator, and you get your y value. That tells you the points that you put onto your grid, and then draw a line through it to graph it. Alright, so the next one here is a method 2, which we use what we call intercepts. So intercepts are where they cross the x-axis and y-axis, alright? So the x-intercept is where it crosses x-axis, the y-intercept is where it crosses the y-axis. So it's important to know that the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. Alright, so we use these two facts to find where they cross. So if I draw out my equation first, so 3x minus 2 equals 12, I'm going to find the x-intercept first. And I know that occurs when y equals 0. So all I need to do is replace that y with 0, so we get 3x, take away 2 times 0 equals 12. Well, 2 times 0 is 0, so that can just disappear, and I'm left with 3x equals 12. Now remember, 3x is the same as having 3 times x, and the opposite of timesing is dividing, so we'll divide by 3. Those 3's cancel out, and we're left with x equals 12 divided by 3, which is 4. So my x-intercept is at 4. Now if I do the same thing, but now I'm going to do the y-intercept, and I know that occurs when x is 0. So this time it's going to be 3 times 0 equals negative, sorry, not equals, take away 2y equals 12. Well, I know that 3 times 0 is 0, so negative 2y equals 12. And again, that negative 2y is the same as having negative 2 times y. So we're going to divide by negative 2 to both sides. Those will cancel out, and we're left over with y equals 12 divided by negative 2, which is negative 6. So I know I have an x-intercept when x equals 4, and I know my y-intercept is when y equals negative 6. So if I quickly draw up a number plane such as that, I'm going to put a blue dot here at x equals 4 and a blue dot down here at y equals negative 6. I then can get my ruler and draw a straight line connecting those 2 points, and that is going to be my, what was the equation? 3x minus 2y equals 12. So a couple of things to recap. Remember, table of values, you control the x's. So if I zoom back up here, you control the x's on the top row and you substitute those into the equation to find your bottom row. You use these points to draw your line. Your intercept way is where you find your x and y intercept. Now the x intercept occurs when y is 0 and the y intercept occurs when x is 0.